Hey guys, today we're going to be talking about 5.5, okay, which is all about continuing to build equations of lines given certain characteristics though. Today we're going to be talking about two key terms, the word perpendicular and the word parallel. We have to have an understanding of what these two words mean before we can start talking about the actual assignment and what we're going to do. How we use those definitions to help us build specific lines. So first, most of you have a pretty good grasp of what it means to be parallel. Most of you would probably describe parallel as lines that are never going to touch. And that's generally true on a flat surface. We're going to say that that's a characteristic of parallel. In other words, if the two lines are in the same plane, yes, we can say that parallel lines will not intersect. Now, in terms of what we've been doing, something that would be useful to us to understand about parallel lines when it comes to building equations, it would be that the slopes, okay, are equal or equivalent. Okay, what that means is that if the slope of line 1 is, let's call it 2 over 7, then the slope of line 2 would also be 2 over 7. What that allows us to do is to interpret situations and build equations by knowing something not about our line, but about its parallel line. So in other words, if I tell you I want to be parallel to y equals 3x plus 5, I know without any hesitation that my equation must say y equals 3x. Now, it can be any b value I want. That I still don't know. That'll depend on what point I want to pass through and other things like that. But parallel means that this slope has to be the same. Okay? Conversely, when we talk about perpendicular, we're looking for a specific type of interaction or intersection. Perpendicular is any line that crosses through another line at a 90-degree angle. Okay? It's really important that we have this in the world that we live in because it creates stability in structure. So when we talk about building a house, we need perpendicular walls. We don't want walls that are tipping in 2 degrees or 3 degrees, or over time it becomes unstable and it can collapse. So we want to make sure we keep things nice and structured and rigid to be able to provide safety for those who are inside of buildings. Well, these slopes of these two lines clearly cannot be equal to each other. In fact, we can tell that one of them is positive when the other is negative. So there must be some difference in the slopes. And if we take a real close look at it, what we learn through some investigation would be that the slope of one line is perpendicular to the slope of a second line if and only if, this must be true, okay, the slopes are negative reciprocals. Now you might say, Mr. Welch, I don't even know what you just said. Okay, so first let's start with the term negative. Okay, so there must be a sign difference. Sign difference. So one slope is positive, the other is negative. We can't have both positive slopes or both negative slopes. And then reciprocals would be exemplified by something like 2/3 versus 3 over 2, or 1/2 and 2 over 1. Now we got to be careful here. Oftentimes we write 2 over 1 as just 2. So sometimes it might seem like there's no fraction to flip, but remember that if you have a whole number, we can put it over a 1 and then we can flip it. So if I had a line y equals 2x plus 5, and I want to be perpendicular to it, we'll use this symbol for perpendicular. Okay, I know that it would be y equals negative, because the 2 over here is positive, so I've got to have a negative. 1 over 2, right? I flip the 2 upside down, I get 1/2 x plus some unknown b. I still have to find b, but I can tell the slope by using specific words, perpendicular and parallel. Let's take a look at some example problems, which you'll actually be doing in your homework, and make sure that we're good to make sense of it. Let's start with this very first problem. Okay, it says that we want to use the information given to create a parallel line. Okay, so on question number 3, okay, we have y equals, I know that the slope must be the same for it to be parallel. So I'm going to have a 2x here plus the thing I don't know is b. Like last time's assignment, I can take this ordered pair, which has an x and a y, and I can plug those in to help find my b value. So my y would be 3. It equals 2 times my x, which is -1, plus b. This would become 3 equals 2 times -1 is -2 plus b. And since I want the b alone, I'm going to have to add 2 in order to get that 2 to go away, that -2. So I'm going to add 2 over here. That gives me 5 equals b. So then for number 3, I can say y would equal 2x, that's the parallel piece, and since my b is 5, I just write plus 5. These two lines must be parallel. Now what's really cool about it is that the 2 and the 5, they are important because they create the line, but they aren't important for the parallel part. All we really need is the slope. So when we look at 12 through 15, and we're looking at, are these lines parallel? Are these lines perpendicular? I look at just the slope. So here on 12, parallel means identical. I see I have a +4, a -1/4, and a -4. So I would say there are no parallel because none of them have identical slopes. However, there might be a negative reciprocal. I notice that line B is negative and line C is negative. Those can't be perpendicular to each other because I have to have one positive and one negative. So the last chance is for A to combine with one of these two. Since line A has a slope of 4 over 1, I'm going to put a 1 in to give it a fractional slope, I would flip that upside down to produce 1/4. So if I take that, 4 over 1, and the -1/4, do they have opposite signs? Yes. Do they have the same value flipped upside down? The answer is yes. So A and B would be perpendicular. So we don't have any parallel lines, but we do have perpendicular, and it would be A and B. All right. This last part of our assignment, 18 through 26, we're looking through here. We're looking for the term perpendicular to pop up. So let's take an example of like number 20. Okay. We know that our slope for perpendicular has to be flipped upside down. And since this is 5 over 1, I'm going to flip it to 1 over 5 with my x. But I also have to make sure that I have one positive, one negative. Since this is a positive 5, I need a -1/5. And of course, I don't know what b is, but that's what I'm going to find. At this point, I now can plug in my x and my y to help finish this. My y is 1 equals -1/5 times x, which is 5, plus b. 1 equals -1/5 times 5. Use your calculator if you're not sure. Should be -1. Still plus b. To get b alone, I need to get rid of this -1, so I will add 1 to both sides to get 2 equals b. That means that my answer for number 20 would be y equals, my slope that's perpendicular is negative 1/5 x, and since I have a positive 2 for b, I will add 2 to the problem. And there it is. The homework is all about continuing what we've been doing for the last couple of assignments. They're very connected. I hope this helps you and that you find success in it, but you've got to let me know if there are struggles. So communicate early and often. All right, good luck, and we'll see you in class.